Okay, we're going to do practice A, Coulomb's law, number 2. So it says 2 identical conducting spheres are placed with their centers 0.3 meters apart. So we're going to write our given. The distance between them is 0.3 meters. We know that they're the same. One is given a charge of plus 12 times 10 to the negative 9 coulombs. So we'll say Q1 is equal to plus, and I'm just going to write it exactly the way that I see it on the paper. I'm not going to do like a conversion or anything right now, because I can, even though this is not correct scientific notation, I can put it in my calculator like this. And the other charge, Q2, is negative 18 times 10 to the negative 9 coulombs. Find the electric force exerted on one sphere by the other. So I want to find in part A, F. So the forces for part A, the electrostatic force F is equal to K Q1 Q2 over R squared. So F is equal to, now this constant K is 9 times 10 to the 9 Newton meter squared per Coulomb squared. Why is it important to write the units? It's important to write the units because I always want to carry my units and cancel them to check my work. So in case I forget to square something or something else, that's going to check my work. So Q1 is plus 12 times 10 to the negative 9 coulombs over negative 18 times 10 to the negative 9 coulombs, all over 0.03 meters squared. Now remember, when you put this in your calculator, okay, I'm just going to show you again how to do an exponent. So I'm going to show you how to do this one. So I'm going to put 12 EE 9, but that's 12 times 10 to the 9, but I want that to be minus. So now I'm going to press the plus minus sign. And I could do that before or after. So now that is 12 times 10 to the negative 9. And then I would press times 18, but that's negative 18, EE 9 minus equals times 9 EE 9 equals. So that's just the numerator divided by 0.3 squared equals. And then if I want it in scientific notation, I press second psi, which is behind the 5, and then I see my answer right there. So now the answer on my calculator says F is equal to negative 2.16 times 10 to the negative 5 newtons. Now remember that we just went over in the notes, is the negative sign means that this is attractive. So on your sheet, the answer says attractive because the negative means it's an attractive force. So 2.2, because that's correct significant figures, times 10 to the negative 5, attractive. So that's part A. All right, so let's read part B. So part B says, the spheres are connected by a conducting wire after equilibrium. So the first thing I want to say to myself, what does equilibrium mean? So equilibrium means that the charges are the same. So if the charges are the same, what I'm going to do is I'm going to add them up. So what are my charges? I have 12 times 10 to the negative 9 plus negative 18 times 10 to the negative 9. I'm going to add them up and divide by 2. So when I add that up and divide by 2, 12 EE9 minus plus 18 negative EE 9 minus, divide by 2. So this means that the one, remember this is Q1 plus Q2 over 2 is going to give me what the charges are, because when they're in equilibrium that means they're the same. So when I do all this, I get negative 3.0 times 10 to the negative 9 coulombs. But now it says after equilibrium, find the electric force. So now after equilibrium, I want to find the new force. So I'm going to use my same equation. F is equal to K, Q1, Q2 over R squared. So 9 times 10 to the 9 Newton meter squared per Coulomb squared. Now the charges are the same. So I have Q1 and Q2. So it's negative 3.0 times 10 to the negative 9 times negative 3.0 times 10 to the negative 9 divided by 0.3 meters squared. Now when I do all this on my calculator, my force comes out to be 9 times 10 to the negative 7 newtons. Now this comes out to be positive. What does the positive mean? So the positive means that it's a repulsive force, because if I have a negative times a negative, it's a positive. If I have a positive times a positive, it's a positive. So no matter what, that means that like charges repel one another. And that's what the positive means. And that's it. Now that was the longest, hardest problem, because 1 and 3 are much, much simpler. Okay, that one had 2 parts and the other ones don't.